So my original plan was to use a 18-volt computer power supply, as I happen to have a few of these just lying around that aren't actually useful for anything. Though after I found out it was 3 wires, it had 3 wires in there, and I realized that I would have no idea what these wires were, because I didn't make myself, so what the heck are all these wires for? Well, one of them's gotta be ground, one of them's positive, and one of them's negative. And I don't feel like figuring out which ones are which, because something will probably go wrong. So, I decided to use the battery method, which involves taking 3 AA batteries and holding them together using alligator clips. This method is not recommended, and is not effective, especially because this took several hours to do. Of course, I haven't explained what we're doing here, so this is actually pyrite and sodium bicarbonate in a solution of, well, in water. Although, pyrite is obviously not soluble in water, which would have certainly helped if it was. The goal is to do this reaction, where we take a pyrite, we add some oxygens to it, and then we add some water to it to get sulfuric acid, but this did not work. In fact, the first problem with this was that the actual reaction, I had to add sodium bicarbonate to get it to start, which kind of ruined it, probably. Probably is the reason it ruined it, but you'll see at the end it wasn't all the waste, because I got the pyrite back. Anyways, that leaves us with a big question. What actually happened in this reaction? And why didn't the pyrite itself work as an electrolyte? And also, what would have worked? So first and foremost, we'll answer the 2 easiest questions, which are, what would have worked, being the very easiest, use pyrite as the electrode, which would separate out the actual component in pyrite and just leave you with a piece of rust. The sulfur would end up in the water, and you just have a stick of iron, which is very rusty. Alright, so the reason the pyrite didn't work as an electrolyte is that the pyrite itself is not water soluble, but also, if we look at the periodic table, sulfur and iron, I don't think that they have the ability to act like the way sodium chloride would in this. So sodium chloride actually has sodium, which is a very reactive first group, I think it is? First group. We'll just say first column. First column alkali metals are like the most reactive. So this guy, and usually you'll find these guys not actually being bonded, but more of just having like just some kind of weird electrical nonsense going on, but they are still technically bonded. Which this is what we would call just an electrolyte, basically. Is like a positive Na, or no, Na positive bonded to some kind of minus particle, or element, compound, whatever you want to say. And we see that in pyrite, it's actually 2 sulfurs double bonded with iron, which means that it would be probably very difficult for us to just use electricity to break it apart, although it may be possible. Maybe. In like extreme conditions. Lastly, we have to answer the question of what actually have I just made. And at the end here, I do filter out some of the water from the actual pyrite and get back the pyrite. And it still has some of the water in it, but that will evaporate away and it'll just be left with some impurities in it, it'll be fine. But what do we have? Well, upon first inspection, we need to figure out, does sodium bicarbonate react with iron pyrite? And we'll have to figure that out. So first and foremost, whenever we electrolyze sodium bicarbonate, what's actually happening is we are producing oxygen somewhere in there, and we're also probably producing hydrogen in there. So if we look at sodium bicarbonate, it's a carbonate group hooked up to a sodium electrolyte. Now we cannot consider that the pyrite is inert in this, so there is some action between probably the baking soda and the pyrite and the other thing that's being produced by electrolyzing the baking soda. So what I'm guessing is happening is that the actual sodium bicarbonate is electrolyzing into the wonderful substances known as carbonic acid and sodium hydroxide, although it seems it might do something else. I'm not too sure. Which, with these chemicals in there, that would be very interesting. Carbonic acid is actually exhaled from the lungs, so I'm not too sure what that's gonna do, but the sodium hydroxide would definitely do something to the pyrite. As far as the other stuff is concerned, I'm not even gonna try to figure out what happened to it.